Hi friends, good evening. Welcome to my channel Belagali's class. Yes friends, after the completion of integrals of rational and irrational functions, then I will start with the second method. First method is what? Integration by method of substitution. This is second method. Method of integration by partial fractions. Partial fractions. My friends, you are unlucky, you have not studied this chapter at all, partial fractions. It is a big chapter, very useful chapter. I do not know why this CBSC, while framing the syllabus, they have not mentioned about what this partial fraction. But they have mentioned what? Its use, okay? Its use they have mentioned. Anyway, I will explain it. These are the basics of what partial fractions. See my friends, if fx and gx are two polynomials in x and of various degree, then this fraction ratio fx upon gx, this fraction or ratio fx upon gx is called rational fraction. This ratio is known as rational fraction. What about fx and gx? They are the two polynomials. Then there exist, my friends, two different cases. Case number 1. If the degree of the numerator polynomial, is less than the degree of the denominator polynomial gx, above less than the below, then this fraction fx upon gx is called as proper fraction. When it is proper, the degree of the numerator is less than degree of the denominator. The same thing is written here. See, the degree of the numerator polynomial is less than the degree of the denominator polynomial, then this fraction is called proper fraction. Otherwise, what do you mean by otherwise? Other than this, what is this? Less. Otherwise means what? Greater and equal to both it includes. Therefore, if the degree of fx is greater or equal to degree of gx, in that case, this fraction is called as improper fraction. When it is proper, degree of the numerator is less than degree of the denominator. When it is improper, if the degree of the numerator is greater or equal to the degree of the denominator, in that case it is said to be improper. Note, my friends, if the given fraction is proper, then it can be resolved into partial fractions. Now, if the given fraction is, my friends, improper, then you can reduce this improper fraction to proper, dividing the numerator polynomial by denominator polynomial. Yes, what, my friends? If the given fraction is improper, then you can reduce it to the proper by dividing the numerator by denominator. My friends, remember. Then this is very important. Our process is this. If the given fraction is proper means degree of the polynomial in the numerator must be less than degree of the polynomial in the denominator. If it is proper, then it can be resolved into partial fractions. And the method is like this. These are some rules, my friends. Rules of resolving into partial fractions. Rule 1. See, this is the proper fraction. What is numerator? Polynomial, linear polynomial, px plus q. What about the denominator? It is a product of two linear polynomials. If you take the product, it becomes what? X into x is x square. Then degree in the numerator is 1, degree in the denominator is 2, it is proper because degree of the numerator polynomial is less than degree of the denominator polynomial. If it is proper, then this proper fraction can be resolved into pieces. First, a upon the first linear factor plus b upon second linear factor. Similarly, if the denominator contains here, there are two linear factors. You have a upon plus b upon. Instead of 2, if it has 3 linear factors, c, x plus a into x plus b into x plus c, then it is resolved into a upon the first plus b upon the second plus c upon the third. Yes, my friends. While doing the examples, if you have like this, if the denominator contains two linear non-repeated factors, different factors, linear different factors, then what is the partial fraction? A upon the first factor plus b upon the second factor. If there is third, c upon the third factor. So the method of finding, what about ABC? They are the real numbers. ABC we can find by making use of what? A method, a special method. That method we will be explaining by taking the examples with the help of what? Following examples. I will take the examples one by one. My friends, I take 1 more minute. I will explain. See. So this is the second method of integration by partial fractions, my friend. So about this you do not know anything, just some brief introduction I give. If fx and gx are two polynomials in x and of different degrees, then the fraction fx upon gx is called as rational fraction, its name. Further, in the rational fraction, degree of the numerator polynomial is less than the degree of the denominator polynomial. Then this fraction fx upon gx is called as proper fraction. Otherwise, it is called as improper fraction. Otherwise means what? Less is proper, greater and equal to is what? Improper. So in this case, degree of the numerator polynomial is greater and equal to the degree of what? Denominator polynomial. In this case, it is improper. If the given fraction is improper, then that improper you can reduce to proper, dividing the numerator polynomial by denominator polynomial. We can reduce this improper to proper plus quotient. Further, if the given fraction is proper, then it can be resolved into partial fractions, partial fractions. These are the rules. First I give rule 1, then I do the examples based on rule 1. What is rule 1? This is a proper fraction, pi tell. What is the degree? It is a linear polynomial, degree is 1. This is a product of two linear. What is the product? X into x is x square. Degree in the denominator is 2. Then degree of the numerator is less than the degree of denominator, then it is proper. Then this proper fraction can be resolved into, it is a rule. If it is so, write a upon the first factor plus b upon the second factor. It is a rule 1. If there are if there are 3, a upon this, b upon this plus c upon this, then what about a and b? C, they are the real numbers. We will explain how to find the values of what? These A, B, C. I will explain with the help of following examples. With the help of what? Examples, how to find A, B, C and how to find the integration, everything. We will explain with the help of what? Examples. Yes, my friends. In this, these are the integrals plays very important role, general formula. What is it? 1 upon fx into f dash x dx. Integral 1 upon fx into f dash x dx is what? Log of the denominator. As a particular case, my friends, you know it. Integral 1 upon ax plus b dx is what? Is it x? No, other than x means divide by coefficient, log. Mod of the denominator, ax plus b, as usual, plus c. 1 by x is what? Log x. 1 by x is log x. If you wanted in one or two cases, you may have integral of 1 upon x to the power n dx. What is this? Minus 1 upon 1 power less. Even power of x is also same. It is what? Coefficient and power are same. 1 less to the given power. Yes, my friends. This is what? Another formula we use while doing examples on this, my friends. Yes. Note it. I will start with examples. These examples you may have under 3-mark questions. 3-mark questions. This is second method. Yes, friends. Evaluate integral x upon x plus 1 into x plus 2 dx. Yes, friends. This is a proper fraction. Consider this separate. Consider x upon x plus 1 into x plus 2. Yes, friend, what is it? A upon first factor x plus 1 plus b upon second factor x plus 2. I am explaining the method how to find a and b. Explaining the method how to find the unknowns a and b. Yes, my friend. Multiply both sides. By, my friends, yes, denominator of LHS. What is the denominator of LHS? X plus 1 into x plus 2 by x plus 1 into x plus 2. Yes, my friend. Totally cancels, remains x equal to a into what cancels? X plus 1 cancels, you are left with x plus 2 plus b into x plus 2 cancels, you are left with x plus 1. You name this as identity 1. Now I have to find values of a and b. See, to find a unknown, first unknown, to find a, you have to make what? This 0. You can't put b 0, why it is a constant? No. Then you have to put what? Its coefficient 0. Put x plus 1 equal to 0. When x plus 1 is 0, what is the value of x? Minus 1, where you are putting in 1. You are putting in 1. Yes. X is minus 1, a into x is minus 1 plus 2. Plus what about this? B into 0. I tell my friend, you have taken this equal to 0. Yes. Simplify it. It is a into minus 1 plus 2 is 1. This is 0, my friend. Therefore, what is the value of a? A is minus 1. Understood. A is minus 1. How we find it? To find a, put the coefficient of b equal to 0. To find b, automatic. Put the coefficient of a equal to 0. Yes, my friend. To find b, put coefficient of a. What is it? X plus 2 equal to 0. X plus 2 equal to 0. Tell from this what is the value of x. Value of x is minus 2, where you are putting in 1. In 1 here. X is minus 2. This is a into, you have taken 0, plus b into. What is the value of x here? Minus 2. X is minus 2 plus 1. Simplify. Minus 2 equal to, this is 0. B into, what is it? Minus 1. Minus upon minus. Plus. So the value of b is 2. Value of b is 2. Hope understood this. This every part is about the partial fractions, my friend. This is the rule. According to the rule, it is written. After writing a and b, we must know the method how to find a and b. This is the method. What is this? You have to multiply both sides by denominator of LHS. Is this multiply cancellation left x a into plus 1 cancels plus 2 remains b into plus 2 cancels plus 1 remains. You name this as equation 1. Next, my friend, from the equation 1 to find a, make this in 0. Put x plus 1 in 0. Taking plus 1 this side is minus 1, where you have to put in 1. Put x equal to minus 1 in 1. X is minus 1, a into x is minus 1 plus 2. But what is this x plus 1 in 0? Yes, my friend, this becomes 0. A into, yes, 1. A into 1 is a. What is the value of a? Minus 1. Similarly, to find b, put the coefficient in 0. With the help of this, you get the value of x is minus 2. This minus 2 you are substituting in the equation 1. Yes, my friend. It is minus 2. A into 0 plus b into minus 2 plus 1. Minus 2. This is 0. Minus 1. Minus 1 minus 1 cancels, gives the value of b is 2. Then, where? You have to put the value of a and b here. Therefore, x upon this equal to a minus 1 upon this plus b 2 upon this, my friends. Right? Therefore, we get this is x upon x plus 1 into x plus 2 equal to a upon a is what? Minus 1 upon first factor plus b is what? 2 upon second factor. See, they are nothing but what? Taking that side, this plus 1 becomes minus 1. What is this? This plus 2 becomes minus 2. Yes, you have to integrate both sides. Integral of this LHS. Integral of LHS. Dx. Yes, that minus is out. It is 1 upon x plus 1 dx plus that constant 2 is out. Integral 1 upon x plus 2 dx. Apply this formula. What is integral of 1 upon ax plus b? Log ax plus b and other than x divide by coefficient. In both the cases, the coefficient is 1. Coefficient is 1. Write it. It is minus log x plus 1 plus 2 log x plus 2. Plus, when both are log, you take what? Log c, constant. C, 2 is a constant, even log 2 is also what? It's a constant. Is it correct? When both are log, you take what? Instead of only c, you take log of c. Simplify by making use of what? Property of logarithms. My friends, I told this. What I told? Log of u to the power p into v down w. I have taken everything here. Power, multiplication, division. What is it? Power becomes coefficient p log u. Product plus log V. Division is minus log W. Therefore, you reverse it. Therefore, you reverse it. P log U plus log V minus log W. We use this property. See, log. Tell. Coefficient is power. Coefficient is power. Plus is multiplication. Minus is division. I hope understood, my friends. My friends. This is the theorem. We are going what? Right from the RHS to LHS. How? Coefficient. Coefficient is power. Plus is product. Minus is division. Log of this entire thing. Use it here. See, my friend. Equal to log mod. Minus means it is a down. It is what? Plus 2 coefficient. Coefficient means what? X plus 2 the whole square. Hope understood. See here. P becomes power. 2 becomes, what is your U? X plus 2. X plus 2 to the power 2. Plus is into. What is this? C. Again, don't write C. Don't write C. Yes. Otherwise, use your property for this. You write only C plus C. Plus C. Plus C. This is the examples, my friends. My friends. I hope clear. Yes. Friends, this example I told comes under what? 2 or 3 mark questions, not more than 2 or 3. Then it is okay. The allotment of the marks is less. Method is something lengthy. So in this case, to cut this method, you can do it another method that is called as oral method. Oral method. I do that partial fraction by oral method, not by integration is correct. We can reduce right from here to here. This method, this we can reduce it by another method. See, my friends. From here to here. See the length. I explained here. Then okay. Yes. I take this proper fraction. It is x upon x plus 1 into x plus 2. Yes, what I write first? I write 1 first. I write 1 upon x plus 1. First factor I write. Side bracket. This side bracket contains the constant. How you get it? To make this 0, what is the value of x? Otherwise you put directly what? X plus 1 is 0. Get the value of x. What is x? Minus 1. This value of x we are not substituting in this. Why? If you substitute it becomes 0. 1 by 0 is undefined. To avoid it, don't substitute x equal to minus 1 in this factor. Where to substitute in the remaining? X is minus 1. X is minus 1 plus 2. Yes, right. The second factor plus. It is 1 upon x plus 2. Same method. Put this equal to 0. What is the value of x? Minus 2. Don't put here. Why? If you put x equal to minus 2 plus 2 becomes 0. 1 by 0 is undefined. Other than this factor, you put it. X is minus 2. Down. X is minus 2. Minus 2 plus 1. Minus 2 plus 1. Simplified, my friend. Simplified. So what is this? Yeah, it is 1 upon x plus 1 minus 1 upon plus 1 minus 1 upon plus 1 is what? Minus 1 plus 1 upon x plus 2 c. Minus 2 upon minus 1 minus 2 upon minus 1 is what? 2 c. This is minus 1 upon x plus 1 plus 2 upon x plus 2 c. You can write it in 3 steps. 3 steps. What about here? So many steps. Yes, my friends, this method of what? Oral method is allowed even in the examination. We can do it. Without hesitation, we can do this method. I will explain once again how. This is your given proper fraction. To resolve it, write first 1 upon the first factor is written. Find the value of x by equating this to 0. By putting this equal to 0, what is the value of x? Minus 1. That minus 1 you put in the remaining, except this remaining. Minus 1 plus 2. Write the second factor is written. Put this equal to 0 and get x. X is minus 2. That value, except this in the remaining. Minus 2 upon minus 2 plus 1 here. Simplify it. Minus 1 upon plus 1 is minus 1. Minus 2 upon minus 1 is plus 2. Directly integrate. This is little bit time saving because 2 mark question, otherwise 3 mark question. If you find it correctly, they give 1 mark. To write what this integral correctly, they give 2 mark question. Yes, my friend, I do one example with taking the 3 map. 3. And one more thing, this method is useful. You can apply it only when the denominator contains linear factors, not other than linear. If they are quadratic, x square plus 1, no, you can't put it. Method is different. You must go with rules method. In this case, it is a direct method when the denominator contains linear, non-repeated factors. Use this method. Yes, the second method is evaluate, friends, it is x upon or 2x upon, it is x square plus 3x plus 2. This can be written as 2 being a constant, you can take it out. Integral x upon. Can you find the factors? Yes, sir. The factors are x plus 1 into x plus 2 dx. X plus 1 into x plus 2. Yes or no? Yes. X into x, x square. 1 plus 2, 3. 1 into 2, 2. Is it same as this? Yes, my friend. Only extra is what? This. 2. Okay, that 2 into that. You put this bigger bracket, write the integral. Same. Next one. On the same lines, my friends, you do it yourself. Integral x upon. It is x minus 1 into x minus 2. dx. Do it. Next. Evaluate. Integral 3x minus 1 down is x minus 1, x minus 2 into x minus 3, x minus 2. Instead of 2, it contains 3 factors, my friends, 3 factors. Consider that integrand. Integrand is this, it is 3x minus 1, denominator, first factor, into second factor, into third factor. Yes, my friend. What is your observation? All the 3 factors are linear. Then we can apply what? This oral method. This oral method. Use it. Use it. Use it. What it tells, my friend, I write here, okay, equal to 1 upon first factor. Yes. Put this equal to 0, get the value of x. X is 1. Why? 1 minus 1 is 0. That we wanted. This value of 1, except this. Remaining, it is 3 into 1 minus 1. Denominator, it is 1 minus 2 into 1 minus 3. Yes, right, the second factor plus 1 upon x minus 2. What is the value of x? It makes 0. 2. Except middle. 3 into 2, 6 minus 1. Denominator, except this, it is 2 minus 1. It is 2 minus 3. 2 minus 3. Yes. Third factor is there, plus. Third factor, 1 upon x minus 3. What is the value of x? That makes 0. Is 3. 3 minus 3. This you must put where? Except the last factor. 3 into 3 is 9 minus 1. Denominator, 3 minus 1 into 3 minus 2. Simplify this, my friends. Simplify, equal to 1 upon x minus 1. 3 minus 1 is 2. What is this? Minus 1 into minus 2. Minus 1 into minus 2 is plus 2. Plus 1 upon x minus 2. 6 minus 1 is 5. What is it? 1. It is minus 1. 2 minus 1 is 1. What is this? It is minus 1. 1 into minus 1 is minus 1. Plus 1 upon x minus 3. 9 minus 1 is 8. 3 minus 1 is 2. 3 minus 2 is 1. What is 2 into 1 is 2. You write down if you wanted. 3 minus 1 is 2. 3 minus 2 is 1. What is the product? 2 into 1 is 2. Simplified. This is 4. So, 2 into 2 cancelled. You have this itself. 1 upon x minus 1. It is minus 5. It is minus 5 plus minus 5 into 1 upon x minus 2. It is 4 plus 4 into 1 upon x minus 3. Yes, my friends. This is your given integrand by making use of what? Oral method. 2 or 3 steps to get the answer. 1 upon, it is minus 5 upon. This is plus 4 upon x minus 3. Now it is ready for what? Integration. Once again you apply what? Integral what? Log integral ax plus b. It is 1 by a into log ax plus b. If a is 1, as it is, log of denominator. Alright, friends. Therefore, integral of integral of 3x minus 1 upon x minus 1, x minus 2 x minus 3 dx equal to, friend, first integral 1 upon this, my friends, integral 1 upon x minus 1 dx. Now this minus 5 is out, being a constant coefficient. Minus 5 out. Integral 1 upon x minus 2 dx. Plus 4 is out, my friends, this. 4 is out, this. So it is integral 1 upon x minus 3 dx. Yes, friend. It is a log mod x minus 1 minus 5 log mod x minus 2 plus 4 log mod x minus 3. If you don't want, you write it as plus c. Yes. Apply the property for these. Log, yes, my friend, mod. Plus you write above, x minus 1 is above, plus, down. Minus means down, coefficient becomes power. It is x minus 2 to the power 5. I hope understood. Minus, down, coefficient, power of this, x minus 2 to the power 5. Plus, plus means what? Product. What is it? X minus 3, coefficient is power. Plus c right here, if you want. Habit of writing plus c. Habit of writing plus c. This is, my friends, when the denominator contains 3 repeated roots. If you apply this method, this is fit under what? Either 2 mark, otherwise 3 mark question. If you go with the method, what is that method? Writing A by first, B by second, C by third. The example becomes quite lengthy, Therefore, normally they go with what? Some simple example. Simple means containing 2 factors in the denominator, 2 linear non-repeated factors. Normally, my friends, normally. Otherwise, they have to give this example under 5 mark. 5 mark, especially in our, according to the model question paper, there is no provision in 5 mark questions. I hope it is clear. Yes, my friends, 1 minute, just see, observe it. Copy it. Yes. Next, man, I do 2 or 3 examples. In that, after substitution, the integrand becomes what? To resolve for partial fractions. Once again, they are the examples under what? Denominator contains non-repeated linear factors. We can use what? This oral method. Yes, my friends. This. Evaluate integral x square upon x square plus 1 into x square plus 4. X square plus 4 dx. Yes, my friend, what is the substitution? Put x square equal to t. X square is t. No differentiation. Why? Tell x square is there in the numerator. Therefore, otherwise you do one thing when you consider that separate first. It is x square upon, take it separate. X square plus 1 into x square plus 4. Consider this. If you want, you can write here. Consider. Yes, my friend. Consider. Substitute in this x square equal to what? Put x square equal to what? it becomes what? This equal to, I write here itself, this is y upon, this is y plus 1 into no, okay, okay. Y plus 1 into y plus 2. Why? Because x square is y. X square is y. Yes, my friends, this you can resolve. This we can resolve. We can resolve only when the linear factors are not quadratic, only linear. That is why it is quadratic. With a substitution, it is made linear. Now use that method, oral method. What is it? Write the first factor. Bracket. What is the value that makes this denominator 0? Minus 1 plus 1 is 0. Except this, it is minus 1 upon. It is minus 1 plus 2. Plus second factor. 1 upon y plus 2. Yes, friend. It is what? Minus 2. Minus 2. Minus 2. Except this, it is minus 2 plus 1. Same, already we have done. Simplify it. 1 upon minus 1 upon plus 1. Minus 2 upon, it is 2, my friend. Minus, no, 1 minute. 1 minute. This is, y is minus 2. Plus 1. Plus 1. Yes. Minus 2 upon minus 1 is plus 2. Now you can integrate it. Therefore, integral of this y upon y plus 1 into y plus 2 dy. Okay. Go back to in terms of x square only. Yes, here. This is minus 1 upon. What is your y? X square. Plus 1 plus 2 upon. What is your y? X square plus 2. Substituted for x square equal to y. So this equal to, yes, partial fraction. You go back to the x square again. Y is x square. Y is x square. 2 in the numerator, minus 1 in the numerator. Integrate both sides. Therefore, integral of x square upon x square plus 1 x square plus 1 into x square plus 4 dx equal to minus 1 is out. Integral 1 upon it is x square plus 1 dx plus 2 is out. This 2, my friends, this 2 is out. This is x square plus 4. This is 4. Then the changes are there. Yes, plus 4. Y is minus 1 upon minus 1 plus 4. Minus 1 plus 4 means it is minus 1 upon 3. Yes, this is minus 1 upon 3. This plus. I hope it is what? Y is minus 2. Y is minus 2. This is 4. Then this becomes minus 2 upon plus 2. This is minus 2 upon plus 2. Which is minus 1. This is minus 1. Yes, my friend. It is minus 1 by 3. What is it? X square plus 1. It is minus 1 Is it correct? It is minus 2 upon plus 2 is minus 1. Minus 1 upon x squared plus 4. X squared plus 4. Yes. It is also minus 1 by 3 first. Minus 1 integral. Right. It is 1 upon x squared plus 4 2 square dx. Yes. Which formula, my friends? Tell which formula? Rational. Tell which formula? Integral. It is dx upon x square plus a square or a square plus x square is 1 by a into tan inverse x by a plus c. If a is 1, it is integral. If a is 1, 1 plus x square. A is 1. It is tan inverse. A is 1. X by a, x by 1 is 1. Applied. It is minus 1 by 3. It is tan inverse x minus 1 by a tan inverse x by a plus c. Yes, my friend. Hope understood. This is your example. Put x square equal to y. This integrand converts in terms of y. Sorry, I was taken to, my friends. Corrected. Please note this correction. It is not 2, it is 4. Yes, friend. Oral method. Written 1 upon the first factor to make it 0. The value of y is minus 1 upon minus 1 plus 4. Y plus 4. To make y is minus 4. Y is minus 4. This y is minus 4. Y is very bad. Y is minus 4. What is this? It is minus 4 plus 1. Is correct. Is correct. Here you have to put, here y is minus 4. This minus 4, here, other than this, minus 4 plus 1. Yes. Here, what is this? Y is minus 1. Y is minus 1 here. Minus 1 you have to put in the remaining. Minus 1 upon minus 1 plus 4. Here y is minus 4. Minus 4 upon minus 4 plus 1. It is correct. This, it is minus 1 upon 3 plus. This is 4. 10. What is it? Minus 4. Minus 4 plus 1 is, it is minus 4 upon minus 3. It is minus 4 upon minus 3. It is minus 1 by 3. What is this? Minus cancels. It is 4 by 3. 4 by 3. Down is x squared plus 4. I hope it is correct now. Substitute. Yes. Minus 1 by 3 into this. It is plus 4 by 3. This. Minus 1 by 3. It is plus 4 by 3. 4 by 3. Tan inverse x by a. My friend, still you have to write one more step. 4 by 3. 1 by a. 1 by a. Tan inverse x by a. Plus c. Simplify it. Minus 1 by 3 tan inverse x. Uh, 2 cancels, my friend. It is plus 2 by 3 tan inverse x by 2 plus c. I give 1 minute, man. Just go through all the steps. If any corrections, because somehow we have done more corrections, my friends. More corrections. See it. All right. Yes. Yes, friends. Yes. Next one. Next one is evaluate integral 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 cos x upon this is 1 minus sin x into 2 minus sin x dx. Yes, here itself, because why? In the numerator you have derivative of what? Sine. Derivative of sine is cos. So here you have to put what first? Put sin x equal to t. Differentiating cos x, derivative of x equal to derivative of t. Therefore, substituting in the given integral, gi, given integral, yes. This is integral, what is it? Cos x dx is dt. Down is 1 minus t into 2 minus t. 2 minus t. Now you consider only this integrand. Consider it is 1 upon 1 minus t into 2 minus t equal to first factor. What is the value of t? 1. In the remaining, it is 1 upon remaining 2 minus 1. Second factor plus 1 upon 2 minus t. What is to make 0? 2. Except this, numerator is 1. Numerator is 1. 1 upon, it is 1 minus 2. 1 upon 1 minus 2. Simplify this. Simplify this. It is 1 upon 1 minus t. This is 1 upon 1 plus 1 upon 2 minus t. This is 1 upon minus 1. 1 upon minus 1 is this. Now you find the integral of this, then you substitute there. Therefore, integral of integral of 1 upon 1 minus t into 2 minus t dt equal to, this is 1 itself, integral 1 upon 1 minus t dt. You have minus 1 here, my friends. It is minus integral 1 upon 2 minus t dt. It is integral of LHS written, integral of RHS, this. Yes, my friend, right. Therefore, integral of this is 1 upon a minus 1 log mod 1 minus t by same formula. same formula. Minus 1 upon this minus 1 log mod 2 minus t plus c. Simplified. This is minus log mod 1 minus t. Minus with minus is plus log 2 minus t plus c. Property of logarithm, log mod plus factor is above, minus factor is down. Then directly put the value of what? Value of what? T, it is log. What is t? Sin x. Down 1 minus sin x plus c. This is what? Integral of given integral equal to this is the value. Direct. Given integral is this. So integral of this is this. Substituting here, given integral is what? Log 2 minus sin x upon 1 minus sin x plus c is the answer. C is the answer. My friends, on the same basis, you do it yourself. Do it yourself. Integral e to the power x upon 1 plus e to the power x into 2 plus e to the power x. My friend dx. 10. Instead of sin x you have e to the power x. Instead of minus here you have plus here. Still better. See. In this case, my friends, you have to put what? E to the power x equal to t. Differentiate. E to the power x, derivative of x is dx equal to derivative of t. What is this? dt upon 1 plus t, 2 plus t. It is what? 1 minus t, 2 minus t. It is 1 plus t, t plus. Same thing, my friends. Do it. Do it yourselves. Same. It is also DIY. Integral. It is 2x dx. Denominator is x square plus 1 into x square plus 2. Tell, what is the substitution? X square is t, 5. Derivative of x square is 2x dx. In this, you have to put what? X square equal to t. Differentiating, it is 2x dx. Is dt. This is 2x dx is dt. Then this integral becomes. So, given integral is 2x dx is dt. Denominator t plus 1, t plus 2. T plus 1, t plus 2. Yes, my friend. Once again, you can use what? Oral partial fraction. You can evaluate this. Okay? This man can do at home. Only 1 or 2 examples I do in the next class. Yes, copy it. Yes, friends, this is enough. Wait, this class, yes, study well, it is good. This partial fraction is one of the basic method, my friends. My friends, if you join the higher classes, such evaluation of integrals by using what? Partial fractions may help. So, remember. So far, I have explained with the first example the method. In the remaining examples, explained with what? Oral method only. But type 2, rule 2, no, I can't use what? This oral method. I have to go with what? Method, A by B by, like that. Yes, my friends, enough. Yes, bye.